Hi guys, welcome to our second video in our first chapter for chemistry. In this video, I'm going to talk about the scientific method and then how scientists research and what that really means in chemistry. So to begin, a quick refresher on the scientific method. This is not a hard and fast set of rules. This is more like a guideline for research. If you go into any research lab and you ask them what step of the scientific method you're on, they are going to look at you like you're crazy. It's not something that, it's a process that we're always in. All right. So, and it's not something that's explicitly thought about all the time, but it is important that we know. First thing in the scientific method is you've got to ask a question. This guides what you're doing. Maybe my question is, how do stars form in the solar system? And that's a question we're trying to answer. Next, we should always start by doing some research. Maybe somebody has already found the answer that you're looking for, in which case you can skip your research. Or maybe somebody's already found a lot of background information so you can pick up without having to reinvent the wheel every time. Once we've done some research, we want that hypothesis. Again, that's just an initial proposed explanation that you will assess by your experiment. The experiment is actually collecting data. Finally, we move towards our analysis where we look at our experimental data and we say, what did it show us? And we end with a conclusion. Considering our findings, what do we now know about our original question? Can we answer it or can we not? Do we need to do more tests? And conclusion is going to, and you can see this arrow here, conclusions inevitably lead us back into a new question, which shoots us right back into this research cycle. So just making sure that you're comfortable with that process. Now, some vocab words to specifically talk about research in chemistry. We have an experiment. This is a scientific procedure done to make a discovery, test a hypothesis, demonstrate a fact, etc., right? Done for some specific and professional purpose. A controlled experiment is what chemists focus on. Chemists are most often working in a lab. They almost always deal with a controlled experiment, which is simply an experiment where you've held everything constant except for one factor that you're changing. That one variable that you can control, that you change, is called the independent variable. That is the variable that the scientist controls. Maybe it's time interval. I say I'm going to measure your position every 10 seconds. I decided 10 seconds. I could have done 9 if I really wanted to. But since I control that aspect of the experiment, that's what's called the independent variable. Next, we are going to have variables that depend on the experiment. Those are called dependent variables. The variable that you're actually looking at. If I'm measuring your distance every 10 seconds, then the dependent variable is your distance. The independent variable was your time, right? All right. A control is any factor that's just being held constant in your experiment. Usually we have a lot of controls. We have one independent variable, one or two dependent variables coming out. And then all data can be put into two broad categories. Qualitative data, meaning it concerns qualities. These would be things like color, shape, feel, size, that kind of thing. And then we have quantitative data. Quantitative data talks all about quantities or amounts. This might be a measurement, some statistic, a weight, something with a number on it is going to be a quantitative finding, quantitative data. All right. So I want to talk about how we come to conclusions in science. And we can see here that we start by making some observations. These observations lead us to a hypothesis, which we then toss into an experiment to test. We'll get some conclusions out of our experiment, and we'll adjust our hypothesis, which probably will bring us some new observations and maybe some new hypotheses. So you can see we're into a loop here. If this experiment fits with some broader class of studies, then we could include it in a part of a theory. Well, theories do have to be tested by experimentation, and they can either be revised if that experimentation disproves some earlier aspect of the theory, or they could become a part of the formal theory or the scientific law. A theory being a hypothesis supported by many experiments that explains something, and a law being a summary of accepted facts of nature And this would be a description of something. So theory explains, law describes. And that's how we produce our endpoints of science, really, our theories and laws. Now, as part of this, often scientists create models. These are representations of a phenomena. They can be visual, verbal, mathematical, any other way you can think of, but they are trying to represent that system on paper. And I have, for example, here, you can see several different models. I have models of the atom, and you can see this is just a visual description of how people thought about the atom over the course of history. We can see we start with a little undifferentiated sphere all the way up to, in 1913, what we would consider maybe our best model of the atom that we use, the Bohr model, and then even into quantum mechanics being a somewhat complicated model that we'll talk about, but won't use as much. But again, these are helping us think about what we're looking at. Atoms don't actually look like this. Instead, this is a model showing us many of those qualities. Also, you can look, we have a model of the solar system here, model of the human body, this globe here. Again, they're shrunken down versions of something we're studying to help us come to conclusions. That's a model. Oh, right here, I have a quick law versus gravity or law versus theory to go back. Notice that in Newton's law of gravity, it's an actual mathematical equation with variables. And in the theory, Einstein's general relativity is the theory that explains why gravity happens. And notice this is in English. It says space-time curvature causes attractions, right? So we have a law and a theory just for gravity, and they are different. All right, moving on. So the ultimate goal of many scientists is, of course, scientific research. And we have many different types of research, and three major ones I'd like to talk about. First, we have pure research. This seeks to gain knowledge for the sake of the knowledge itself. Maybe I would like to construct a model for what does a lithium atom look like, just so I know what lithium looks like. That would be called pure research. That'd be something I have this one on the right here. We typically do pure research in the in like a research laboratory. Next, I would have my applied research. This might be some research that is applied to a specific situation to actually solve a problem. Maybe somebody is saying, "Oh, I am looking to design a material that could be used in a bulletproof vest." And we're researching, how do these nanotubes stand up to, pressure? Like, are they strong enough to stop an impact from hurting somebody? That would be applied research trying to actually solve that problem. If we think about technology, this is our practical use of scientific information. So technology would be actually making the bulletproof vest out of these nanotubes. That would be a piece of technology. Again, it's applied scientific information. So, and that is our intro to chemistry. And for all of these, remember, this is kind of a review, probably stuff you've seen before. So, if you have any questions, please feel free to ask. I did keep these fairly short though, so I may have missed some stuff. Just make sure you remind me. All right, guys. Thank you for listening. I'll see you guys in the next video. Bye, guys.